will understand this from mechanics perspective. नहीं तो आप ऐसे see charges and all are na very hypothetical. Have you seen a charge? You have not seen a charge. Charge will be moving. The thing which you have not seen, how does it move? How do you know? So this has to be understood, because next you'll learn this topic in grade 12, and right now in grade 12 we are doing this chapter only. It is one chapter. The whole potential concept is one chapter. So let's understand. We will learn two topics today. The book teaches you two topics: electric potential at a point, electric potential difference. These are two topics that we will learn. How we learn them, we will see. One is electric potential difference. Okay. And if you have understood, go and explain one of your friend also what is this thing all about. And the other concept is electric potential at a point. Very, very topics which are, you can mug up a definition, but I'm sure you will not understand head and tail of it. Okay. So let's first understand what we do in physics. Okay. In physics, you study about a quantity. That quantity can be what? Temperature, pressure, right? Volume. That quantity might be potential. That quantity might be current. Any quantity that you study, you actually want to measure this quantity. These are classical physics. And once you measure this quantity, you get a value. For example, the potential energy is so many joules, right? Or you can say the temperature is so much Kelvin. But in actual sense, you never measured the quantity. You actually measured what we call as the difference between. You always measure the difference. You always measure the difference. You do not measure any value directly. Let's see some example. Let's say your age. You say that your age is 14 years. Right? You say your age is 14 years. No. You're saying your age is 14 years because the day you were born, you are taking your age as 0 years. This is your reference. So what you have measured is the difference between the day you are born and the day to day. Number one concept. Okay. Number two, let's talk about something called, let's talk grade 9. Suppose this height is h and a body is here. The mass of the body is m and acceleration due to gravity is g. So this much is the weight of the body and you have lifted it through h. Work done is equal to force into displacement. Force is mg. Mg is acting downwards, so you are giving force worth mg and you are lifting it through h. So the energy that is stored here, you say that the potential energy is equal to mgh, because the potential energy is equal to the work done. हमने जो पसीना बहाया to take it up, I've shed my sweat. Where did that go? That is gone and stored here as energy. Now if you put Anurag's head right under it and you release this, tabak, it will smash his head. That means this has gone the capability to do work. So it has energy. Where did that energy come from? My muscular energy got converted to potential. And when I release it, it smashes his head. The potential is converted to kinetic energy. And this is conserved. There is no loss. We call them as conservative. So the force you applied was also gravitational force. That is a conservative force. Conservative force does not depend how the work was done. What I'm trying to say is, suppose there is a staircase like this, right? A man is taking the staircase, but after taking the staircase, he reaches a height h. Potential energy gained by him will be mgh. Whether he goes by the staircase or he goes from here, the path is not important. It always depends on final and initial points. These concepts you'll study in grade 12. These are called conservative forces. A conservative force will give you a conservative work. Conservative work means this work is never lost. Converted from one form to another. Potential energy converted to kinetic energy. Similarly, how you went doesn't matter. It matters what is your final position and initial position. Have you understood? How you went, it doesn't matter. How much height you gained. Now you say that the potential energy here is mgh. No, it is not potential energy. It is the difference in potential energy, because you assumed that the height here was 0. So you said that the potential energy here is 0 and the potential energy here is mgh. What if for a person who might be seeing this from the burial ground below his coffin. For him, this is also a height. आप समझ में आ रहा है what I'm trying to say? We never measure potential energy. We are always measuring potential energy difference. Therefore, in the book of CBSE, this point is at first. We'll not study this. We'll first study this. Difference समझ के then you can understand. Just see the logic. What is your age difference? 14 years. How did you find it? My present age minus my age on the date of my birth. Then I ask you, what is your age difference? 14 years. What is your age today? You say age on this date minus something. That minus something is 0. Then you get the age. So once you know potential difference between 2 points, you want to find out the potential here, आप इसको 0 कर दो. Then it gives you what is the potential here. Are you understanding? What is the potential at this point? The potential at this point is the difference of the potential here and here. Here it is 0, so automatically whatever is the potential at this point. Is this logic getting clear? This same logic we will apply while understanding this concept. Book teaches this first. Lakbir Singh will also teach this first. Understand this first. इसको समझने से ये समझना एकदम आसान है. Ready? आइए. If you have not understood anything at this stage, do not hesitate. Please ask, because when you go to grade 12, this will all seem ekdam, what do you call? Delete button? There should be a delete button, right? Yeah. This will all become, okay, let's understand the concept of electric potential energy, or electric, not energy, you don't have energy, but we'll first understand energy, then only we'll understand what is potential difference and all. Okay. Definition for this in your book is the work done in moving a charge between 2 points, what our friend was saying all the. This is समझ में नहीं है, समझो पहले. आओ. Let's understand a mechanical system. Okay. I have a mechanical system with a spring loaded. This is a spring. Okay. Say. And first you understand. अभी आपको समझ में आएगा. This is a spring system. Okay. Very commonly we study this in mechanics. This is a spring. The spring is right now in uncompressed state. The spring is right now in an uncompressed state. Obviously, you do not feel any sort of force on you. So what you do, what you start doing is, पहले आप इसको समझिए, फिर आप drawing बनाइए, नहीं तो आपको मजा नहीं आएगा. What you are trying to do is that you are applying an external force. This is an external force you are applying, right? As you apply an external force, you have compressed the spring out here, right? The spring is compressed. Let's say this was your point, say A, and you have brought it to point B. You have compressed it. As soon as you start compressing a spring, the spring will start giving a spring force back to you. The spring force is such, and you are compressing it not very fast, you are compressing it very slow, such that your force and the spring force is all equal, right? The net force on this object is 0, which means the object is not accelerated. These all things we will study in the charge also. This object is not accelerated. When does acceleration come? When net force comes. So we are pushing it very slowly in accordance to the spring force that is getting developed. And the spring force is directly proportional to the displacement. More you compress, more will be the spring force. And you bring it here. Now ask, what is the state of the body here? The body is energized. Because if you leave this body now here, patak karke this will go away. This is known as elastic potential energy. Potential energy by virtue of position or constraint. This is constraint. You have constrained it. छोड़ दे मुझे. ये वो वाला हाल है. Release me and see what I can do. And you release it, it will just tuck go away. What happens? The entire potential energy gets converted to kinetic energy. There's no loss of energy. This is a conservative energy. Now let's see how you got this potential energy developed on it. Once you are giving that external force, right, and you are displacing it, say, through a distance x, then what is the work done by the external force? The work done by the external force is F into x. Do you agree or not? Right? And what is the work done by the spring force? The work done, if you see this is the external work, and let's see the work done by the spring force. The spring force work done will be equal to the spring force multiplied by the displacement. But the spring force is on this side, the displacement is on this side. Fs cos 180, and cos 180 is minus 1. So the spring force work is negative, right? So can I now say that the work done, the external work done, can also be represented as the negative of the spring force multiplied by x? External work, because the external force is just opposite to the spring force. Yes or no? Work done by the spring force is how much, beta? F. Work done by the external force is Fxt into x. What is the work done by the spring force? Spring force into x. But if we try to see the spring force work, it is negative of the external work. इतना आपको समझ में आया कि नहीं? The spring force, yeah, tell me. You are applying a an external force on this body, and you are trying to compress it. As soon as you start applying an external force, see, that's why I say be very attentive on this class, otherwise you'll lose track. As soon as you apply an external force, the spring will give a spring force from its side. Which side does the spring force work? The spring force will work on this side. Spring to वापस भेजेगा ना उसको. Now you ensure that you are applying the force in such a manner so slowly that you do not exceed the spring force. Your force is equivalent to the spring force. In other sense, this body is moving with zero acceleration. It can move, na? Acceleration is zero. Net force acting on the body is zero. This you keep in mind, because we don't want the body to accelerate. At this position, when you are moving the body from here to here, you are doing something which is known as an external work. And your external work is the external force multiplied by the displacement that you have moved. Work is force into displacement. Do you agree? If you want to see this external work, now how are you seeing this external work? You are seeing it from the perspective of the external force. Which side is the force? This side. Which side is the displacement? This side. What is work? Fs cos theta cos 0, which is equal to 1. But if I want to see this work done from the spring force perspective, how is the work from the spring force? Then the spring force is acting on this side, and the work is happening, the displacement is happening on this side. Then for the spring force, it is a negative work. Have you understood? This external work, if I want to do it in terms, if I replace this force by the spring force, I have to put a minus sign. Is this much understood or not? Right? So when we put an external force and we bring it out here, don't you think that this body has got energized? No doubt about it. So let's say the potential energy at this point of the body is UB. Yes. Before you started, as I told you, everybody has some potential energy. You have given, say, there is a potential energy here called UA. Have you understood? So the system gains energy or loses energy as you compress it, the system. Tell me, does it gain energy or lose energy? Gains energy. I will be sweating to push it. System gets energized. It's like a bow. Now it's energized. Right? So the change in energy of the system is given by final energy minus initial energy. Do you agree or not? Right? And what is this change? This change is nothing but the external work that you did on the system. Yeah. Suppose your energy was some burgers. Your energy became burgers plus nuggets. What is the change in energy? Nuggets. How did those nuggets come? You only supplied. My work done has got stored, and it When we talk about the change in potential energy, we are least bothered what was your energy here or what was your energy here. Doesn't matter. Doesn't matter. Your and my age difference is 32 years. No matter which part of the world or which part of the calendar we measure, we are always 32 years apart. So we are working on the change in energy. हमें कोई मतलब नहीं यहाँ कितना energy है, यहाँ कितना energy है. But the change in energy is always this energy minus this energy. Is this concept understood or not? And why does the energy change? The energy changes because I have done external work. I have spent work. Where did my work go? My work was stored in the spring. So my external work is equal to this energy. Mind you, we are talking about something called potential difference. What you learned with me just now is potential energy difference, not potential difference. Itna samajh mein aa raha hai? We have to go here. And this is all about charges. You might say, sir, you are explaining mechanical system. We are supposed to study electricity. That we will understand. If you are, is this analogy understood? Right? This analogy is understood because you feel that whenever you are actually doing work on a system, the system adds up energy to it. And the addition of the energy is equivalent to the work that you have done. This analogy understood? Delta means what is the difference of energy? You had energy worth 500 joules. I compressed. Aapki energy बढ़ गया ना अभी. Energy means of the block. Don't you think the block's energy has increased? It has become 700 joules. So what is the change in energy? 200. And say suppose we take another block, its energy was 100. And whatever was the same work I will do on this also, then its energy will increase to 300. Because I am adding only 200 energy. Got it? Your pocket money was 20 rupees. I give you 50 rupees. What is your pocket money? 70 rupees. What is the difference? 50. His pocket money was 1000 rupees. I gave him 50 rupees. What is his pocket money now? 1050. How much is the difference? 50. I'm worried only about the difference. To me, it doesn't matter. So I say he today morning got richer by how much? 50 rupees. You got richer by how much? 50 rupees. Is this understood now? This is one analogy of understanding. Let's see another analogy. Okay? And then this concept will become crystal clear to you. So all we will again study is energy difference only. Once again, another concept. Let's see another concept now. So we are on our beautiful planet Earth right now. Okay? We are on our planet Earth. और ये है our apple eating boy Anurag. He is on the surface of the Earth. At the surface of the Earth, we are checking datum from here. Datum means our reference. Our reference line is from here. How much is this potential energy? 0, we will say, because there is no height. But somebody who is living at the core of the Earth, he will say, "Arey, isko paas kitna." See, it's like relative. We feel we are not rich when we see people who are driving Rolls Royce on the road. But the person who does not have a car or does not have a cycle, for him, me with a Honda Activa is also very rich. It's very subjective, very relative. You have taken your Honda Activa to be the poor standard, 0. So the Rolls Royce guys appears to you as richer. Right? So what we do, now you have to understand one more concept, and that concept is known as the gravitational field of the Earth. Okay? Let's understand that concept also. 1 minute. Yeah. So the Earth has got a field around it, which is known as the gravitational field. Sir, what is this? This is some sort of a chakravyu around the Earth, that whenever you are in this field, Earth tries to attract you back. Earth tries to attract you back. That's why the satellite has to be launched beyond this gravitational field. So a body which has got mass, he has an aura around him, which is known as the field. How do you feel the field? It is like one dada. The Earth is a dada, and the dadagiri around him. More you are near to the dada. Jaggu dada hai. I am a big dada of say Pebble City. Is my dadagiri felt by these Shreyas and the Anurags and all? No, they are indifferent. Will my dadagiri be felt by somebody in Gurgaon? No, not at all. But mathematically, there is some dadagiri in Gurgaon also. You are not feeling it. The moment you come to my Pebble City, you say, "यहाँ पे जरीब दादा रहते हैं." You understand? So this is an aura around the body. A body with mass has a gravitational field around it. Sir, does a ball have a gravitational mass field around it? Absolutely. So, sir, when I actually put a pencil above the ball, it falls on the floor. Why doesn't it go to the ball? Because the mass of the earth is more. The earth is attracting. Space में ले जाके ball रखोगे तो ball तक ही आएगा. Everyone has. Now what we are trying to do, so please understand, the gravitational force, the gravitational field always will create one sort of a invisible force which is trying to bring everybody towards the center. Right? Now we do some work. What is the work we are going to do? We are going to do a work in pushing our friend Anurag above from the earth's surface. उठा दिया उसको हमने ऊपर. Right? Don't you think that you had some spring out here through which you have tried to lift Anurag, analogy wise? Because the earth wants to keep Anurag on the ground, means the spring wants to be uncompressed. While I was lifting Anurag, I was lifting him against the spring. So don't you think Anurag is energized out here? Obviously, release him from here, dhamang niche girega wo. So let us say his potential energy here is UA and his potential energy here is UB. Agreed? And we have done some external work. What is the external work? This external work was done against the gravitational field of the earth. Try to understand. This external work was done against the gravitation. Earth says, Anurag, be here. I said, no, I will pull him up. If I convert this to a simple system, I am actually pulling Anurag against a spring. Right? Am I sweating for that? Yes. Where is my sweat going? Stored in him as potential energy. So whenever you are doing work against a gravitational field, you are adding energy to the system. I can again have the analogy of what is the change in energy? The change in energy is given by energy at B minus energy at A. In other sense, Anurag now has the capability to do some work. If he falls down, he can fall down on something. Is this logic understood, all of you? So by now, with two discussions, we have understood something. If any external work is done on a system and the work is conservative, means there is no loss. Acha, what work? We did work against what? Gravitational force. Gravitational force is a conservative force. All work done by gravitational force is conservative. You did it in grade 9. You saw that potential energy here, total energy here is always constant. And that was against what work? That work was done by gravitational force. So gravitational force is a conservative force. A conservative force is not worried about what path you took, but from where to where you went. So it is only dependent on final and initial. And the conservative force does a work which is known as a conservative work. This external work was a conservative work because we worked against the gravitational force. Is this understood? So the story moral from here is, if you do an external work on a system, you will be adding energy to the system if you are working against some field of the system. Here you are working against the gravitational field. इतना समझ में आया? हमने ज़माने के against में काम किया. We worked against the world. So we have to push. And when we push, we energize the system. Because system wants to come back to its original shape. Time now to get into electricity with this concept. इतना समझ में आया? Now let's get into this with the electricity concept, okay? So what did you learn? One thing here, a body which has got a mass, a body which has mass has a field around it which is known as the gravitational field. And if your body is very big, like a Saturn, a Uranus, a Earth or a Mars, you have a gravitational field around you and you will be sucked into that field. And if you do any work against that field, you energize the body. Now we come to our concept of electricity. Now in electricity, what do we say? We have a charge which is say Q. A Q is a positive charge. समझो, पहले समझो, फिर लिखने का पूरा time. Or you will not be asked questions from here. You will be asked that definition. But you should know how that definition comes. There's a charge Q. Now we said matter has got two properties. Matter produces mass from which it contributes to weight, gravitation, from which there is a gravitational pull between two bodies. Two electrons also pull each other because they have mass. The pull is not that strong. And then we said there is another force, which is the electrical force, which arises due to another property of matter, which is known as charge. So this is charge. Every charged body also has a Dadagiri aura around it. Though you don't study it in grade 10, but we will study, otherwise our concept will become difficult. So what is the Dadagiri? Like that was known as electrical, that was known as a gravitational field. This Dadagiri is known as electrical field. Electrical field. Sir, what is electrical field? They say, like, have you seen Conjurings? When first all things will happen, they will first call the father of the church. And when he enters, you will see, I do smell there is a bad spirit haunting you in this house. And she wants to possess. They can sense that. The electrical field is the region around a charge in which its presence can be felt. What presence, sir? Does it have eyes and teeth like this and eat somebody at night? No, it's an electrical body. If you bring another body, that will also have some charge in it. Based on the polarity of that charge, this body will either pull that charge or repel that charge. Wahi to hai. That is the presence of electrical field, right? If there is an electrical field and you bring a, what you call a meter around it, think like a scientist, bring a meter around it, you want to check there's electrical field or not. So the meter will actually emit one small positive charge. And if it faces any repulsive force, yes. Or it will emit a negative charge small. If it emits any attraction forces, yes, there is the spirit. There is a spirit out here. This is electrical field. Now let us see how the electrical field behaves. Because in grade 8 we studied that if you have a gravitational force, which is a non-contact force, it is always attractive. But when it's an electrostatic force, it can be attractive as well as repulsive. That means this electrical field is not going to behave similar like a gravitational field. Gravitational field always attracts. So let us understand the concept of electrical field first. The concept of electrical field is such that you can have either a positive charge or a negative charge. Electrical field is shown by something called electrical field lines. They always come out like coronavirus, which are radial. Radial. अब आप कुछ मत ड्रॉ करो, आप just समझो, these are radial. अच्छा, what is it trying to show? It is trying to show that a positive charge has an outward electrical field. What electrical field, beta? Outward electrical field. Okay. Sir, how did you know that outward? You must have tested it. Yes, I tested it. And the testing charge in electrostatic is denoted always by something called Q naught. And Q naught is assumed to be positive, but almost tending to zero. It itself has no charge. Minimum. But whatever minimum is there, that is positive. This is my test. If you want to test what you call a sweet shop for its taste, whom will you take? अब भूखा बच्चा लेके जाओगे ना, पर एकदम भूखा ले जाओगे तो वो चल ही नहीं पाएगा. थोड़ा सा घर से खिला के ले जाएंगे, one Mary biscuit, one Mary biscuit. But whatever, we did not put fingers in his mouth and puked him. We put some positive. थोड़ा सा जो भी है थोड़ा सा positive है. So a test charge, remember, a test charge is always positive, whose charge value is almost negligible. Now, why is it negligible? Why is it negligible? Listen, if I make you eat it up full tummy and I take you to the sweet shop to taste sweets, will my examination be neutral? Not at all. आप तो सर एक लड्डू भी ट्राई कीजिए और लड्डू से आपका टेस्ट न्यूट्रल नहीं होगा. So I have to take you very hungry. Have you seen Munna Bhai MBBS? They say, poor India, I want poor people, poor. You have to take very hungry person so that he goes on and eats. Laddu is good. Balusai more tasty. Baklava even tasty. This is tasty. So you are taking a very bhuka bacha. Understood? And test charge is bhuka. Now, if you bring the test charge near this positive, what will happen? Repel. So the electric field line always shows the direction how a test charge behaves near it. That's why for a positive charge, the electric field lines are radially outwards. Because if a positive charge comes here, he will face repulsion. Do you agree? And the electric field lines for a negative charge is always shown radially inwards. These are concepts. Now you have understood why it is radially inwards. Because if the positive charge would have come here, वो तो चिपक जाएगा इसके साथ. हम अभी भी आपके चैप्टर में नहीं घुसे हैं, आपके चैप्टर में ये दो है, इसका डेफिनेशन समझने की कोशिश करना है. इज दिस अंडरस्टूड? इन फिजिक्स whenever we try to define a system or understand a system, we take a positive charge. Sir, why are you taking a positive charge? By birth, when a child is born, we assume he will be right-handed. He may be left-handed, but 99% right-handed ही होगा. तो हम right-handed लेके study करेंगे. We'll always go with a positive. Such a charge is known as source charge. Source charge means which has value, the sweet shop. And the guy who will bring near the sweet shop, he will be known as the test charge. Got the concept? Another scientist opinion is, why is the test charge taken negligible? It is taken negligible because if you add charge to it, he will also have a dadagiri region. Na? Yes, he will also have a dadagiri. His dadagiri will impact this dadagiri, which we don't want because we want the measurement of this electric field. Is this clear? Now, in order to, I am a very renowned goon of my area. If you want to check my real threat and my trauma, bring the most helpless guy around me. If you bring a guy who has some courage, then you are not testing my courage. It will be my courage minus the courage which he will be afraid, no doubt about that, but not as afraid worth my tyrant or whatever you say. Concept samajh mein aaya? So this is a source charge. Now, in this source charge, there is an electric field around, right? And the electric field is how, beta? Moving outwards. Take. Now we bring our small little what? Test charge. We take our test charge at one point Q. This is at one point A. This is our test charge, right? Test charge is what in nature? Positive. Does it have any charge? No. Now we move this test charge. Very kalpanik discussion, huh? We move this test charge to a point B, right? How do you move it? Sir, as soon as you will start to move it, it will start facing an electrostatic force of repulsion. Try marrying it with the spring concept now. It will face an electrostatic force of repulsion. So I have to apply something which is known as an external force. And I'm moving it through a distance x. Don't you think I am doing some external work? Yes. Am I doing this external work against something? Yes, against this field. And the field is creating that electric force. So electric force says, hey, mat aao. I said, jaiye na. Mat aao. Jaiye na. Very slow. Why slow? Net force should be zero. Charge should not be accelerated. Because on day one, I told you, if a charge is accelerated, it will create a wave. Charge cannot be. Charge will be with constant velocity. Very, very slow movement. And you are coming from A to B. Don't you think you have again done something like the spring wala job and you have brought it till here? Yes. So the energy of the charge here is UA. This is the electric potential energy. And the energy here is UB. Don't you think that you have added energy to the system? How much energy did you add? You added delta U, which was equal to UB minus UA. Obviously, UB is greater than UA because you're doing work against the field. Clear or not? So an external work done against an electric field creates a potential difference. And that potential difference in our case is positive. Why? Because we have done work on the system. Charge here will be now energized. If you remove your external force, the charge will be immediately kicked up. Also, he will just get out from here. Yes or no? All the potential energy gets converted to kinetic energy. No loss. So electric force is also a conservative force, which you will be studying in grade 12. So work done by electric force is a conservative work and does not depend how you brought this charge. Sir, if I would have brought it like this, doesn't matter. If I would have brought like this, sir, I would have brought it like this. It only depends on final and initial point. And that energy difference is known as the electric potential difference. Clear? Itna samajh mein aaya? Anyone has doubt till here? हाँ. Yes, source charge can be negative. बड़ा अच्छा क्वेश्चन, यही तो नगला बोलने वाला था. If this source charge was negative, see, no, I really like that question. If the source charge was negative, socho, source charge negative, then do you need to do some work? No, वो तो खुद ही यहाँ आ जाएगा. At that time, the energy here is more, the energy here is less. This is what in grade 12 students struggle. That if it is negative, then your work done has no value. You're doing negative work. You're doing a compressed spring, you are extending it more. What work are you doing? But there's a difference. In that case, if you would have moved the charge from here to here, then you are adding work to it because it's a negative charge. It wants to pull you. Now here the charge is energized. If you release it, it will come here. So if that's why that becomes difficult concept, we take it positive. It was negative, then the external work done is negative. System loses potential energy. If it was negative, then a positive charge here has more energy. Therefore it comes. Your energy will be always spent in the direction of the field. Anurag came in the direction of the field. He never went away. Charge will always come in the direction of field. Negative hoga to charge will come this side. Then why do you need to work? ये तो ऐसे ही आएगा. Here you need to work. Very nice question. Clear? In there UA will be greater and you need not do any work. आपको work करने की जरूरत नहीं है. Why are you working? It is, you are saying, sir, from a height, do I need to carry the stone down and put it on Anurag's head? No, just release it. It will automatically fall. Energy there is more. Energy here is less. But sir, from here, if I want to lift it, he will not. Then you have to do work on the system. Clear, Abhi? Okay? So now we are ready to go to potential difference. Okay? Tell me now, at this stage, though you understand something which is known as electric potential energy difference. This you have understood. Okay? Your grade 10 topic talks about electric potential difference, but you have understood electric potential energy difference. What is electric potential energy difference? You said electric potential energy difference. Okay? I'm going to say something, just observe what I'm saying. Electric potential energy difference delta U is said to be the difference of energy between 2 points UB minus UA. UB minus UA. Don't write, just understand. UB minus UA. When you try to move a test charge Q naught from a point A, which is your initial point, to a point B, by doing an external work EXT A to B. I'm just writing, just understand. What is electrical potential energy difference? Obviously, when you say difference, means you have to have 2 points. Electrical potential energy difference between 2 points B and A is said to be, mind map, is said to be the external work done in moving a test charge Q naught from A to B, where A is my initial, B is my final. In doing so, the difference of energy that is created between the final and initial is said to be the electric potential energy difference. So can I not write that delta U was nothing but the work external done from A to B? Have you understood this or not, what I tried to say? Try to write now. You try to write from this. And I want you to put this cross sign also, because you don't have energy difference in your syllabus, you have potential difference. So how do you write it? You write it like this. I have 2 points. Just try in this. Make 2 points on your copy. Make 2 points, A and B. Just mark 2 points A and B, anywhere, A and B. Right? उल्टा लिख लियो बेटा, A इस साइड लिखो, B उस साइड लिखो, नहीं तो तुम्हारा डायग्राम रॉन्ग हो जाएगा. A on the right, B on the left. Have you made 2 points? And just look at me what I say. Now introduce one test charge Q naught. Introduce, right? Q naught, and write for Q naught, what is it? Test charge. Test charge means bracket में क्या लिखोगे? Q naught is positive and has negligible charge. And has negligible charge. Clear? Now our job starts. We move Q naught very slowly. So put one asterisk and write, start moving Q naught very slowly. Write that line, start moving Q naught slowly. Start moving Q naught slowly. Slowly. From A towards B. राघव सुनते जाओ लिखते जाओ, आपका भाषा उसके साथ टैली नहीं कर सकता है, पर आपकी समझ और उसके समझ में डिफरेंस नहीं होना चाहिए. लैंग्वेज कैन बी एनीथिंग. सो देखो, once again look at me. I have a point A, I have a point B, anywhere in space. A और B 2 पॉइंट हो गए. Now I created a test charge Q naught. भूखा बच्चा. What is his speciality? थोड़ा खा के आया है घर से. Little bit. That means has some charge, negligible. What is the nature of the charge? Positive. समझ में आ गया? So third person introduce. अब क्या करना है? Take that test charge and start moving it from A towards B. कुछ कंडीशंस के साथ. कैसे मूव करेंगे? Very slowly. Zero acceleration. No net force. है ना? तो वो इस चीज को लिखिए अभी. आपने Q naught को इंट्रोड्यूस किया. Now your next job is to move Q naught from A towards B. Move Q naught from A towards B. Yeah, sir. Velocity is not zero. The net force is zero. It's uniform velocity. No acceleration. It's just like you are going on cruise on ORR. ठीक है? You're not writing anything, Vakula. Okay, very good. Have you understood? So Q naught was introduced. Now what do we do to Q naught? Q naught is being moved very slowly. In what manner? No net force, no acceleration. Where are you moving Q naught? You are moving Q naught from A to B. And then you write next point. Next point. I feel a resistance. I feel an obstruction. I feel an opposition. एक opposition होगा ना? I feel an opposition created by the electric field of the space. Created by the electric field of the space. Acha, once you have written this, let's go back and understand one more thing. See children, I drew this source charge. Suno, sun lo. I drew this source charge. And there I am trying to move these two bodies. We may not show the source charge also. Source charge is shown to show that there is some field. Between 2 points in space, if you move one body from one point to another, you have to still do work. The earth is there. That is the source mass. उसको आप नहीं भी रखोगे, means if you hide this portion also, you are in the Dadagiri region of some charge. This I had drawn to show you. That means in your diagram, when you are writing that you are moving it charge from one body to another, you are moving it in space. That space is also having some electrical field due to some charge. So you face a repulsion, right? And so you are doing, you say, what did you write? You said, we start feeling a repulsion because we are doing the work against the electrical field, right? This work is called the external work. This work is the external work. This work is the external work. Right? And now you come mathematical. You cannot write so much of English. So you write this as WEXT A to B. WEXT A to B. The work is shown as, means it is an external work done to move a charge from A to B. ठीक है ना बेटा? You are moving it from A to B, and you are moving it in A to B against a electric field. Against an electric field. That's why the potential will be developed, means against the electric field. That means you can draw this diagram also. You are trying to move it this side. यही है ना concept, against an electric field, right? Now you write the external work creates a difference in potential energy creates a difference in potential energy between A and B. Between A and B. So when you're writing A, bracket you write WA, and when you're writing B, you write UB. Means UA is the potential energy at A, UB is the potential energy at B. This external work creates a difference in potential energy between A and B, such that UB is greater than UA. UB is greater than UA. And delta U is equal to what? UB minus UA. Delta U is equal to UB minus UA. What happened? Sleepy, not writing anything. Sleepy है तो घर से अटेंड कर बेटा, कोई बात नहीं, पर मन लगा क्लास में. UB minus UA, which is further equal to WEXT A to B. Now you have written the entire Ram Kahani. Take a time to read your Ram Kahani, whether you have, all of you read the Ram Kahani you have written to understand whether you have understood what you have written. एक बार पढ़ लो तो. Did you understand what you have written? The last part is simple. Where did you last write till? You tell me.
Creating a difference in potential energy.
Creates a potential energy. That means you have not understood. If you have understood, you write creates a potential energy difference delta U, which is equal to UB minus UA, which is equal to WEXT A to B. ऐसा काम करने में अनुराग क्या हुआ? दोनों पॉइंट के बीच में पोटेंशियल एनर्जी का डिफरेंस क्रिएट हुआ. इन व्हाट मैनर? दिस पोटेंशियल एनर्जी इज मोर देन दिस. व्हाट इज द डिफरेंस? दिस एनर्जी माइनस दिस. ये आया कहां से? द एक्सटर्नल वर्क दैट यू डिड. यही तो हमने लिखा. If you accelerate a charge, a wave will be created. Charges cannot be accelerated. Yes.
But is it like there's a spring placed between A and B and we're just moving it towards B?
So A to B you are moving, that means it is getting energized better. Try to understand. See, before I am all okay with questioning, but to question you have to first absorb what I am saying. Immediately don't try to re-question the concept. If you are moving from A to B, आप पूरा सुनो चीज को. You are moving from A to B. Why did the energy increase? Because there is an electric field against you. You are working against the electric field. An electric field produces an electrostatic force. That was my idea of drawing 3 slides. I first showed with a spring. A spring produces a spring force. I am working against the force. So am I not energizing it? Yes. मैं वहां पे छोड़ दूंगा तो ठप करके मेरे मुंह पे आएगा. It has energy. Next example, what did I show? I showed Earth and Anurag. I am trying to take away Anurag from the Earth. Earth says मेरे पास रखो. मैं कहता नहीं ऊपर ले जाऊंगा. So I am pushing Anurag against a spring. Am I energizing him? Yes. In the third example, I have replaced Earth with a charge, which has an electric field going outwards. And I am trying to now bring a positive charge towards the positive charge. वो बोलेगा मत आओ मेरे पास. I don't want you. नहीं मैं लाऊंगा ही. So am I not energizing the system? Yes. So that's what I'm saying. What did I write? I wrote that there are 2 points in space A and B under influence of an electric field. And the field is such that it is moving from B to A. You are trying to bring a test charge. Sir, what is a test charge? A charge whose value is almost 0. Some minute charge is there. But whatever is there is positive. एक पॉजिटिव को पॉजिटिव के डायरेक्शन में ले जाने की कोशिश कर रहे हो. जाने देगा? नहीं देगा. So aren't you feeling like you are working against a spring? Yes. I am still applying force, and after applying that force, I have taken it here. Have I done work on it? Yes, I have sweated. Where did my work go? My work has gone and added as potential energy of that charge. Means the potential energy at B is now more than that of A, and the difference is known as UB minus UA. And this difference, no matter how much, the same example that I gave, 2 children, one was very rich, one was not that rich, but I gave them only 50 rupees. So how much richer are they? 50 rupees. So the delta U between these 2 points is worth the work that I did. This is the 50 rupees I gave to both the children. So their difference is how much? 50 rupees only. This is electrical potential energy difference. Is this concept understood? Now we come to your syllabus. Electric potential difference. Okay. Before that, in this concept, you have to see one more thing. Suppose somebody is interested, sir, understood all this. Can you give me what is the value of UB? What are you wanting? The potential energy measurement at B. So my friend now says that delta U is equal to UB minus UA. My friend says, sir, I don't want this difference. I want how much rich I am, total my richness. I want this. So what is this known as? Potential energy at B. Potential energy at A. Acha, I need to find this. Then I say, we cannot find this directly, but we can do some mathematical jugglery. By any way, if we make this equal to 0, this part if we make equal to 0, then whatever is the difference, that is like exactly in today's world what you're doing. What is your age difference from your birth? 14 years. What is your age today? 14 years. Age today. What is your age difference? 2026 minus 2011 or 8, whatever you were born. No, I want your age on 2026. ठीक है, इस age को 0 कर दो, तो ये age मिल गया. Now we want the potential energy measurement, not difference. So we have to make UA 0. अब UA को कैसे 0 करें? If you are on the surface of the earth, height is 0. If you are born on this day, age is 0. These are all concepts you have taken. So एक concept इसको भी दो. So what is the concept we say to this? We say, if this point is A, is shifted to somewhere called infinity. Where is infinity? I don't know. Can you feel my dadagiri at infinity? No. No, we don't know where is infinity. So my dadagiri at, we say that the potential of any system at infinity is taken as 0. Potential of any system taken at infinity is taken as 0. Now come back here. This is a concept. So if I now replace this as delta U equal to UB minus U infinity. So what is my story? Listen, my story is I am moving a test charge now from infinity to B. Now you Rockwell guys, you must have learned when a charge is moved from infinity, padha hoga na, that infinity word. Have you studied or not? You have. When you studied electric potential at a point, that infinity word 100% is there, which you might have forgotten now. So if you are moving from infinity to a point, infinity's potential is taken as 0. This value is 0. So whatever is the delta U, that is the UB. So if somebody now says, what is electrical potential energy? Suppose somebody says, what is EPE at B? What is EPE at B? Let's see you can define or not. The EPE at B is equal to the external work done when a charge is moved from infinity to that point. Same condition, slow. Because then the definition comes delta U equal to UB minus infinity. Clear? We need to study what? Electrical potential difference. In electrical potential difference, it's just a simple thing. The test charge is replaced by any charge. And this is called unit positive charge. इसका मतलब क्या है? This has a value of +1 coulomb. +1 coulomb. Okay? +1 coulomb. And this is known as the external work done in moving a charge from A to B per unit positive charge. Per unit positive charge. अब आप टेस्ट चार्ज मत लाओ, कोई भी चार्ज ले आओ. Now you might ask something like this, say, sir, you did a work of WEXT when you were moving a test charge. अगर सर मैं बड़ा चार्ज ले आया तो? Another child says, sir, if I would have brought a medium charge then. So the question is something, gulab jamuns are sold from this shop. Sir, he brought 2 kg, they charged 200 rupees. Sir, he brought 4 kg, they charged 400 rupees. Is this a better way to say? Or should we say, What is the per kg charge? 100 rupees. You buy one truck, you buy only one. The rate is fixed. This is not like a rate. The work done per unit charge. Now it doesn't matter. You bought test charge, you brought big charge, you brought pumpkin, you brought rat, whatever you brought. The work done per unit charge, unit positive charge. In moving it from point B to A is known as the electric potential difference. And electric potential difference is not shown. Now you cannot write U for this. So we now say it like this, that there are 2 points. This is the point B, this is the point A. And you are moving what beta? You are moving a unit positive charge, Q. Q की value कितनी है? +1 coulomb. You are moving it from A to B. And then you say that B will have some potential called VB and A will have some potential which is called VA. Why am I not writing UA, UB? This is potential, not potential energy. And the difference in potential delta V is given by VB minus VA. And what is VB minus VA? W external, work done from A to B, divided by the value of Q. Clear? So in other sense, you can write like this also. Delta V is equal to delta U divided by Q. What is delta U? W external from A to B divided by Q. What is delta U? UB minus UA divided by Q. What is delta V? VB minus VA. Potential difference between 2 points. In your grade 10, they marry this with this. But these are also correct. Potential energy difference between 2 points is said to be the work done per unit charge in moving a body from A to B. Clear? Right? Okay. So you understand what is electrical PD. Potential difference in this chapter will be called as PD. PD is equal to W external divided by what? Q, which is VB minus VA, which is also delta V. Now your next topic is what is electric potential, not potential difference, potential at B, at a point. So what is the parent definition? Delta V is equal to VB minus VA. Now you are bothered about this. Look. Now you are bothered about this. So what should you do? इसको zero करना है. इसको zero करना है. कैसे zero करोगे? Yes. Delta V is equal to VB minus V infinity. We will not move it from A. We will move it from infinity. Because at infinity, everything is taken as zero. Then the potential that you measure is VB. So now can you define this? How will we define this? Now see, Anurag, Shreya and Ali, you all have studied this. Now I'll define, it will actually match with your book. The electric potential at a point B is defined as the external work done per unit positive charge in moving it from infinity to that point. Match your book, this is the definition. In moving it from infinity to that point. Q infinity se move kiya? Sir, because we know the parent definition of electric potential difference. पर आपको तो difference नहीं चाहिए ना, आपको मेरा आज का age चाहिए. You want my today's age. Then make your age on the date of birth as 0. How can you make it? By making you born in infinity. This is parent definition. Therefore, book teaches this first. If you understand this and this, it is a difficult thing. First, understand difference. Then understanding potential at a point is very easy. What is the electric potential at a point? Electric potential at a point is defined as the potential in moving a charge from infinity to that point. In moving a charge from infinity to that point. Let us better it. Amount of work done per unit charge in moving it from infinity to that point. What is electrical potential difference? Electrical potential difference between any 2 points is the external work done in per unit charge in moving the charge from this point to this point. Per unit. And when you go to 12, you learn आपने आज 12 पढ़ लिया. एनर्जी के टाइम पे सिर्फ भूखा बच्चा लाना है. पोटेंशियल के टाइम पे कोई भी बच्चा ले आओ. Divide it. There is a very interesting another way of understanding this. You don't understand all these things, just imagine. This is a samosa shop A and a samosa shop B. What is the potential of samosa shop A? What is the potential? Potential matlab, my samosa is so tasty that the business flourishes. So what? Admi kharidta hai. Do people buy? Yes. Yes. How can you prove? Sir, a person from infinity also does external work to come and eat my samosa. So I really have, this is my potential. Okay, very good. Understood. This is Magan Lal Samosa Wala. This is Chhagan Lal Samosa Wala. Someone is more tasty than the other. Someone is more tasty than the other. What is the potential difference between these two? Bring one Bulakkar guy. He may be near here, but the amount of work he is ready to do to come here is basically his potential. Why do they say that Agarwal Sweets, we don't have any branch? To have our sweets of 10 rupees, people burn petrol of 50 rupees. That's our aura. Though he has a sweet shop near him, he still is ready to do an external work to come here. That is my potential. Yahi to potential, na? What is the potential of having, they say na, in the book of management, there is a chapter called Ethics in Management. In MBA, you'll learn that. Where should you set up a liquor shop? Liquor shop, matlab samjho na? Wine shop. They say the best place to set up a liquor shop is right outside an engineering college. The business will be the maximum. Sabse zyada log piyenge. But do you think you should set up a liquor shop there? That is where ethics in management comes. Government does not stop cigarette sales because it adds a lot to the excise revenue. But put something called cigarette smoking is injurious to health. Every bottle of alcohol has alcohol consumption. Fir band kyun nahi karte ho? So that concept always is there. Ethics in management. How much do you oblige? So here when we talk about potential between 2 points, just understand there are two sweet shops. He says, "Mare samosa khane ke baad aap kahin jaoge nahi." So we are here. Let's say, for example, we have a restaurant in Pebble City. Still you sometimes order food. You are paying extra delivery charge. Why? That means that shop has more potential than this shop. That you are ready to do an external work to still come there. Iska potential zyada hai. And say, suppose this, we are now, that's the first tower in Pebble City. There's nothing in and around us. What is the potential of this particular shop? The potential of this shop is that any person in between 5 kilometers, if he feels hungry, he knows there's only one place to go. Where? To that sweet shop. That is his potential. But his potential gets challenged when another sweet shop gets opened. Now it's a potential difference. Where would you like to go? Are you ready to do this external work? Yes. Tasty hai na? Why are you so hungry for a paradise biryani only? That's a different concept. You like it or not. Name, fame, whatever. The potential is more. Even the person not near will go there and have it. वही तो ये चार. उसके लिए आपको वर्क करना पड़ेगा ना. पसीना बहाओगे, आपका पोटेंशियल बढ़ेगा कि नहीं? बढ़ेगा. So today we learned two topics. Electric potential difference. The electric potential difference between 2 points. I could have just said the definition. It would have made my life easy. But I feel with that definition, you will just get some marks in 11. You will again not understand. Just as he honestly said, I didn't understand. The electric potential energy, so the electric potential difference between 2 points is the external work done per unit charge in moving it from one point to the other. What is the electric potential at a point? The external work done per unit charge in moving the unit charge from infinity to that point. And this potential difference, जिसको आप पढ़ते हो ना, PD, this is only known as voltage. Continue our discussion in later class. So if this is your plug point and if this is your TV, this is at higher potential. This is at 240 volts. The TV is not turned on, it is at 0 volts. So when you connect here and you switch on, how does water flow? From higher potential to lower potential. So how will charges flow? Higher potential to lower potential. TV will not charge the point. The point will charge the TV. As simple as that. Brings another question in this, that this is my power bank and this is my mobile. My mobile is fully charged. My power bank is absolutely low. I have connected. Now what should happen? Generally, power bank should charge the mobile. Now my mobile is fully charged, power bank is empty. Who has more potential? Mobile has more potential. Power bank is at lower potential. Now what should happen? The mobile should drain out. है ना? यही तो होना चाहिए, होना ही चाहिए. But for that we give a protection which is known as a, these are interesting electrons, called diode. Means it will be a unidirectional valve. एक ही तरफ खुलता है, इस तरफ नहीं खुलता है, सिर्फ इस तरफ खुलता है. Another example, this is your RO tank. Your RO tank is connected to your tap. Water goes from this side. Sometimes there is no water here. Tanks, water should go here. Na? It doesn't go. We have something called NRV, non-return valve. एक ही direction में पानी जाएगा. Sir, difficult to understand. Think of a pipeline with a small metal out here. And there is a small bar out here, small bar obstruction. When water comes in, the metal lifts. Water goes this side. And if water comes from this side, metal cannot lift because there is this bar. This is called a non-return valve, which in electronics is performed by a device called diode. This diode will not allow your mobile to get drained. Otherwise, if you connect a mobile to a less charging power bank, अपना mobile ही खत्म हो गया, power bank charge हो गया. Think like a physics students. ये सब सवाल आपके धीरे धीरे आना चाहिए. So charge always flows from higher potential to lower potential. That's why, and flow of charge is known as current. इसको आगे क्लास में पढ़ेंगे. टीवी से यहां नहीं जाएगा, यहां से टीवी जाएगा. ठीक है, चलिए. So next class we will define once again electric potential difference, electric potential at a point, that we will see how you measure it, and so and so.